I sense a great disturbance in the Force.
But Emperor, the new blaster is the most powerful weapon in the galaxy.
They better be, Commander.
Well, yeah, they are.
Man, these sabers are fresh! It thinks. What do you think about this triple power button?
Me something!
What the digaba?
Wow. That was intense. I got a guy who can help us out with this situation.
You guys are gonna want to lay low for a couple days.
Wow, with one button, blow the whole damn thing up! Who designed this? Now fix it now!
Oh, he grabbed version 1.0. My bad. Here you go.
Now that's more like it. Let's go eat.
I will lay my vengeance upon you.
I will lay my vengeance upon this burger.
Pass the ketchup, dude.
Now that we have the prototype created, it's time to Jar Jar proof this thing. To start, let's go into Autodesk CFD and do a heat transfer analysis. The first step is to define some materials. We're going to choose all of the external components and define them to be titanium. I'm sure the Jedi are using something stronger now, but we're going to go with titanium to simplify our setup. Next, we have to define the interior components. To see those, we will hide the titanium components that we just defined, and it will show us the gaps between the parts that are made up of air. With those selected, we choose air, and we're left with just two parts, the power crystals. At the heart of every lightsaber is set a crystal that resonates to produce the efficient, powerful blade. Of course, most of these came from the Crystal Cave. Here, we'll define their special material properties to reflect their innate powers. Next, we have to apply our boundary conditions. Selecting a few surfaces allows us to define the temperature at the top of the lightsaber. This temperature is going to be 1600 degrees C. Of course, the Jedi have found a way to make this passive, emitting heat and energy only when using it for cutting or fighting. Finally, we're going to use the Death Star, or the Cloud, to run the analysis and free up our computer for further analysis work. While that runs, let's jump back to Inventor and send the prototype over to Simulation Mechanical. The first step is to apply a mesh to the model, and since materials were automatically imported for us, all we have to do is press the Drop Test Wizard button and get our results. Here we can see the displacement of the drop, and now an animation of the stress and displacement of the lightsaber as Jar Jar drops it off the floor. It looks like we'll see a max of about 20,000 psi, but thanks to the modern materials used by the Jedi, this should be no problem. Our results have returned from the dark side in Autodesk CFD, and as you can see, the temperatures are ranging from 1600 to 20 degrees C. But due to the advanced technology of the power crystals, the handle of the lightsaber never gets too hot. Join us next week for Episode 4, A New Layout, where the Jedi Knights look to optimize their factory floor designs to get ready for mass production.